Okay, so here is a little practical use of this OSC communication between Touch Designer and VCV Rack. This is back in week 1. I showed this just as an example of how you might connect things like Arduino, sensors, different platforms, visuals, and audio, and all this, kind of combining it all in a really multi-sensory way. So we're at a stage now when we can actually understand what's actually happening here. So we've got standard like Arduino stuff with the serial DAT coming in, which is being mapped to a brightness on the level top here. And then we're getting a RGB values from a pixel row in our top right here, sending that out, OSC out to port 7001 with these channels R, G, and B. And so if we look at rack, we've got this hooked up. So here we see these channels R, G, and B. And we've got this being converted, so from 0 to 1, which is what our pixel values are giving us. We're remapping that from 0 to 10. And so we can see that on the oscilloscope here. And this is going down to a VCA mix. So each of these R, G, and B values is affecting the VCA in our 3 channels here. Okay, beautiful. What I want to focus on in this one, so this is using some of the newer modules that we're looking at this week. The Mixmaster, in particular, this little situation here that we're sending data back to Touch Designer. So you can see I've got MIDI CV, so just my computer keyboard, and I've got VOCT stuff happening in here. So I want to kind of show, we can see the cables as they're kind of hooked up right here. What exactly is happening here? So from this offset, that's going out into this value right here. So it's called chords. And how are we using that? So I've got OSCN here, getting that chord value. A little bit of math, just changing the range so it gets into a 0 to 1. And then I'm using that to change the seed of my noise. So let's see what happens when I actually click that. Actually, for it to work, I need this to be up front so I can use the keys, the keyboard. And we can just get rid of that for now. So I'm just using the keys like Z, X, C, V, B, N, M, and comma. So kind of that bottom row of keys. And we can see when I kind of cycle through those different keys, my my chord generator, so the type of chord is changing in this ChordCV by Aaron Static, which is generating different chords. So this kind of also is the first introduction to polyphonic modules. So from ChordCV, you can see it's outputting 3 different channels of VOCT signals. So these voltages consist of just for the C major chord, a C, an E, and a G. And as we change, let's say to a C minor, we can see those 3 pitches change. So that becomes a D sharp, right? So C, D sharp, G, and then back to C, E, G. So we'll talk more in the next video about polyphony and what that means and how we can use it. For now, I want to show, really focus in on this offset. It's such a simple module, but very, very useful. And, in something like Touch Designer, this is what we would use, something like this math. So this from range and to range makes our life very, very easy. We don't actually have to do any math in our heads, some arithmetic. multiplication, plus and minus, all that. So with this, it allows us to do the same thing as what range is doing, but we need to kind of keep the numbers in our head a little bit better. So to do that, let's just look at what kind of range is this voct generating when I hit the keys on the bottom of my keyboard here, and what kind of range do we need going into this type parameter. So I guess first thing we can look at maybe a scope. Also, maybe just while I'm doing this, let's introduce another new module from a new developer called ML modules we haven't looked at yet. So voltmeter is another one. So this will show us the voltage like very clearly written out in numbers, whereas scope, it has like a max and min. We see the numbers, but it's a much more visual type of module. But let's have a look at what's actually happening here. So let's hook this in here and here. And maybe just so the cables don't get too cluttered, let's just look at that. Okay, so voct, I'm going to cycle through. So Z, X, okay, so there we go. C, V, B, N, M, and comma. So here we can see it very clearly. So from Z to comma, that essentially takes us through one octave. Okay, so now I know the range, my voct range from my QWERTY keyboard from Z to comma is from 0 to 1. Okay, great. What kind of a range do I need here in type in order to kind of cycle through all the different types that I want to play with? To do that, we could do something like, maybe get something like 8-vert from the fundamentals. Let's just get rid of that for now. So 8-vert allows us to output manual constant voltage. And so here already I can kind of see an interesting thing. So I'm outputting 0 volts from here, but this kind of jumped to C major 7, which again, if we kind of cycle through, we get C, C minor, C7, C minor 7, C major 7, which is kind of like in the middle there. And then sustained, right? Some other ones right there. So it appears that if I'm sending, 0 volts here, it's going to end up. So right now it doesn't matter as I turn this. So it's purely, getting that from this CV input right here. So the knob doesn't really matter right now. So 0 volts is kind of in the middle. So I think it is actually expecting, and there we go. Yeah. So basically -5 volts to +5 volts is the range that this type parameter is expecting. So, okay, we've got 0 to 1 coming from here. Our destination is expecting -5 to 5. So we have a little arithmetic problem that we need to figure out, right? So how do we, through what combination of multiplication and adding and subtracting can we do that? So I guess to start, and I've already solved the problem here, so let's just maybe put that in one, and we can get like a different color, maybe like green, to compare these two. So let's go back to, default here. Okay. So 0 to 1, the range I'm going to is the range of, there's 10 volts, right? -5 to 5 is a range of 10, whereas my keyboard range is 1. So I need to multiply that range by 10. So on scale here, I'm going to multiply that by 10. And now if I go up like this, right? So Z, X, C, V, B, N, M, comma. So what's coming out of this now is a range from 0 to 10, which is not what I want. I want -5 to 5, right? So now offset, you can just do -5, and then that is going to be in the range that we want. Beautiful. Okay, cool. To be aware of, so in this case, it works out order of operations. Scale goes first and then offset. If we did offset first and then scale, that gives us something different. So it's offsetting first, and then it's scaling it. So that gives me like -5, and then it's being multiplied by 10. So I'm actually ending up with like -50 or something. Like what actually is that? Oh, -12. That's the kind of like, that's a hard minimum, so you can't even go below that. So that's not what we want to do. So just to be aware, by default, this goes scale first, then offset. Whatever reason in the future, maybe it needs to be different for what you need to do. So you can just flip those around, and that's getting us the right range for this one. Okay, so offset scale, very, very, very useful. Other things that do a similar thing, right? This idea of attenuverter. These are essentially the same thing. So if you see this term attenuverter, I mean, all kinds of modules kind of do this. Attenuverter. So very, very common type of module to use, and all these use the same basic paradigm of, one part is changing the gain, positive or negative. So it's kind of like the amplitude or the scale, and another one is offsetting it. So kind of like a plus or minus. But the good old one from Bogue Audio I like, because scale actually goes up to 10x, whereas some of these other ones, like this one by Bafaco, which is also a really great library, only goes up to 1, -1 and +1. So you can't really scale it by dramatically higher or lower values. Okay. And some of these other things, check out the Instro library. So this right here is a really nice low-pass filter. One of the main differences from a lot of other low-pass filters, it's got a mixer built in, so it can accept 3 different inputs. Also, Debriatis, really, really great. It says wave destruction here, but just adding different types of crushing, folding, distortion, saturation. So grab it, play around with it. If you have kind of a clean, pure sound, just play around with these a little bit, and it'll just add a little tooth to it, a little texture, extra harmonics, and it'll sound kind of nice. Okay, cool.